Now let's take a look at integration by parts. And first our formula. Integration by parts says the integral of u dv is equal to uv minus the integral of v du. So let's see what in the world that means. Okay, so our first example, we got the integral of x squared sine x and dx. We're going to choose this to be our u, and we'll choose sine x dx to be our dv. Now, if I go back to my formula here, we need four things. We need u, well actually just, we need u, we need v, and then we need du. So we don't need four things. We need three things actually, but okay, so over here, u is equal to x squared. So du would be 2x dx. Now dv is going to equal to sine x dx. And to find v, we take the integral of that. Well, the integral of sine x gives us negative cosine x. And so now we have u, we have v, and we have du. So we're just going to plug it into our formula. uv minus the integral of v du. So u was x squared. V was negative cosine x. Minus the integral of v, which is negative cosine x, du, which is 2x dx. Okay, I'll simplify this a little bit. I'll take negative, put it on front there. So we got negative x squared cosine x. I'll take this negative, put it out in front, and I'll take the 2 and put it out in front too. So that becomes plus 2 x cosine x dx. Now, one of the powers of the integration by parts is it reduces. See how we went from x squared, now we're down to x. So we're going to do it again. This is our u, and this is our dv. So over here on the side, see u is equal to x, and dv is equal to cosine x dx. Okay, so now we need du, derivative of u. The derivative of x is 1, and then we add on a dx. Now to find v, we take the integral of cosine x dx, and the integral of cosine x is sine x. So then we're gonna continue down with our formula. We're again going to use uv minus the integral of v du. Now this first part remains as is. We got negative x squared cosine x plus 2, and that 2 is multiplied times everything to the right now. Well, u we said was x. V we said was sine x minus the integral of v, which is sine x, du, which was just dx. I'm going to add my plus c at the very end in case you're wondering. Well, now we're to the integral of sine x, and I can find that without too much fuss. So again, this is 2 times this. Now the integral of sine x gives us negative cosine x. And I'm going to put my plus c under now. So I got negative x squared cosine x. And I'll multiply the 2 through. So 2 times x gives us 2x sine x. And here a negative negative becomes positive. So we got a positive 2 cosine x plus c. And that would be your answer. And trying to see if I have enough room here. Let me go look at the next problem and decide. $7x. I should have enough room for that. Let's take a look at another example of that. 7x e to the x dx. Now always, in deciding what to pick, that 7 I could put out in front. So I'm going to go ahead and do that. Not even worry about it. And we've got x e to the x dx. Now always deciding what u is going to be. U should be the one that will hopefully disappear or change significantly if you take derivative of it. So our u is going to be x. Our dv is going to be e to the x dx. So u is equal to x, and dv is equal to e to the x dx. Okay, so we need to find du. The derivative of x is 1, and then we add on a dx. To find v, we take the integral of e to the x dx. The integral of e to the x is just e to the x. And now we're ready to plug in our formula. So we've got uv minus the integral of v du. 7 remains out in front. And I put a bracket because it has to be times everything that follows it now. Well, u is x. V is e to the x minus the integral of v, which is e to the x, and du, which is dx. Oh yeah, this one's a lot simpler. Okay. Now, the integral of e to the x is e to the x. I'll put my plus c on now that I've done the last integral. And I'll sometimes what they'll do is they'll actually factor out what they have in common. Like, see how these both have e to the x's? So they'll factor out an e to the x, and that leaves you x minus 1. Or they might actually just go ahead and multiply it through. So it all depends upon the book and the author and what they do on that. And let me save that page. Integration by parts. Integration by parts. Page 01. Okay, let's look at the next problem. Got x squared, natural log of x, dx. And same instructions, find the integral. Well, if I look on my sheet and see what the integral of natural log of x is, and I'm looking through my basics from Calc 1, and I don't see the integral of natural log anywhere. So I can't let that be my dv in this particular problem. So I'm going to flip these around. Like this. And we're going to let the natural log of x be u. And the x squared dx will be dv. So over here, I'm going to have u is equal to natural log of x, and dv is equal to x squared dx. Now I can find the derivative of natural log of x. It's 1 over x. Not sure where it's on your sheet, but it's 1 over x dx. Now here, I'm going to take the integral of x squared dx, add 1 to our power, divide by our new power. And we get that. Now notice we don't add a plus c on at this point. So now we're going to plug in our formula. So we got uv minus the integral of v du. Okay, so u was natural log of x times v, which was 1/3 x to the third, minus the integral of v, which was 1/3 x to the third, and du, which is 1 over x dx. Okay, I'm going to rearrange this a little bit. I'll put 1/3 x to the third, natural log of x, minus, take the 1/3 and put it out in front so I don't have to worry about numbers. And x to the third over x gives us x squared. So then we got 1/3 x to the third, natural log of x. Just wanted to make sure I didn't bring a number out in front at the very beginning problem and I dropped it, but no, I'm fine. And I got 1/3, and then we'll add 1 to our power, divide by our new power. And now we'll put our plus c on. So that gives us 1/3 x to the third, natural log of x, minus 1/9 x to the third plus c. And that would be our answer. Next problem is kind of a long one. So let me start a new page just to make sure I have enough space. There we go. E to the 3x sine x dx. Now we're going to rewrite that. When we got these type of problems, when a kind of one bounces back and forth and the other one bounces back and forth also, like if I take the e to the x, if I find derivative of e to the x, it's e to the x. And if I keep taking derivative of it, it's still e to the x. The integral of e to the x is e to the x. And the integral of e to the x is e to the x. So never goes anywhere. Now for sine, derivative of sine is cosine, then derivative of cosine is negative sine. It bounces back and forth. And so does the integral. So let's see how this goes. So I'm going to rewrite that as sine x e to the 3x dx. You always want your e to be your dv. I shouldn't say always, but a good percentage of the time it is. So then, this is going to be u, and this will be dv. So u is equal to sine x, and dv is equal to e to the 3x dx. Well, du. Derivative of sine is cosine x, and then I'll put dx on there. And I meant for that to be in black. Let me do that over. Not that matters, but okay. So du is the derivative of sine is going to be cosine, and then we'll add on our dx. Now v will be the integral of this. And within this, I have to use the u substitution. Let me instead use w. So w is equal to 3x. dw is equal to 3 dx. So we need a 3 inside. And we'll offset it with a 1/3 out in front. Like that. And so then this becomes the integral of e to the u du. The 3 dx gets replaced by dw. Why am I putting u's? So used to use. Let's try that again. Okay, e to the w dw. The 3 dx gets replaced by dw. The 3x gets replaced by w. The integral of e to the w is e to the w. And we said that w was 3x. So this would be 1/3 e to the 3x. And pass 1. Okay, so our formula says uv minus the integral of v du. So I hardly have room here, but let me see. I'll squeeze it in. Sine x e to the 3x dx is equal to u, which was sine x, times v, which was 1/3 e to the 3x, minus the integral of v, which is 1/3 e to the 3x, times du, which was cosine x dx. I won't squeeze it in that tight again. It helps to actually be able to see these. So I got sine x e to the 3x dx is equal to 1/3 e to the 3x sine x. Now I'll take that 1/3 and put it out in front. So we've got minus 1/3. And then I'll put cosine x and e to the 3x dx over here. Okay. Now I'm going to do it again. Well, this is going to be u, our cosine x, and this is going to be our dv. So I come over here. U is equal to cosine x, and dv is equal to the integral, not yet, jumping ahead, okay, is equal to e to the 3x dx. Okay, so du, the derivative of cosine, is going to be negative sine x dx. And to find v, we're going to take the integral of e to the 3x dx. Now up above, I went ahead and did all the substitution there to show it. So the integral of e to the 3x is just 1/3 e to the 3x. Now these work out nice when you're using e's for your dv, because they'll always come out the same, so you don't have to do as much work. And this is pass 2. Okay. So then this part right here at the end, I'm going to rewrite using our formula, uv minus the integral of v du. And everything else is going to carry down. So we've got the integral of sine x e to the 3x dx is equal to 1/3 e to the 3x sine x minus 1/3 times everything that follows it. Okay, so we got u, which is cosine x, times v, which is 1/3 e to the 3x, minus the integral of v, which is 1/3 e to the 3x, times du, which was negative sine x dx. Okay, so now we have the integral of sine x e to the 3x dx equals 1/3 e to the 3x sine x minus 1/3, and I'll rearrange these, so that's 1/3 e to the 3x cosine x. Here I'll take the 1/3 out in front, and I'll take the negative out in front. So negative negative becomes positive 1/3, and the integral, and I'll rearrange them, so the sine x here and the e to the 3x is next, dx. Okay, so sine x e to the 3x dx equals 1/3 e to the 3x sine x. And I'm going to take this negative 1/3 and multiply it through now. So that gives us negative 1/9 e to the 3x cosine x. Negative 1/3 times 1/3 also gives us negative 1/9. Integral of sine x e to the 3x dx. Now we could spend the rest of our life doing this and never go anywhere. Past 3, past 4, past 10,000, so forth. What we're looking for is, this is what we had originally on the left side. Integral of sine x e to the 3x dx. We're wanting to keep doing the passes until we get that same thing over on this side. See how I have this now? We're going, since they're the same, we're going to treat this as a variable over here, and we're going to move it over to the left side. So this carries down. So we got the integral of sine x e to the 3x dx. The negative 1/9 of that I bring over, it becomes a positive 1/9. Integral of sine x e to the 3x dx. And this is still here, so I got 1/3 e to the 3x sine x minus 1/9 e to the 3x cosine x. Well, this is like combined together like items, like terms. There's like invisible 1 in front of this. 1 plus 1/9 gives us 10/9. So this becomes 10/9 integral of sine x e to the 3x dx equals the other side. Cosine x. Okay. And we want to get this by itself, so we're going to multiply both sides by the 9/10, the reciprocal of those numbers. So that gives us 1/3 e to the 3x sine x minus 1/9 e to the 3x cosine x. Well, these over here, these 10s cancel, these 9s are going to cancel, and we're left with what we were trying to find in the first place, the integral of sine x e to the 3x dx. Now if I multiply that through, the 9 and the 3 here, that gives me 3/10 e to the 3x sine x. If I multiply this fraction times that, the 9s would cancel, and we got minus 1/10 e to the 3x cosine x. And now here at the very end, I'll add on my plus c. And that would be our answer. It's a little bit weird, but when they fluctuate back and forth like that, all you can do is do your passes until you get these exactly the same. Hopefully I haven't made any kind of adding, subtracting mistake up above. If it does, I'll blame it. Let's see, what's the excuse of the day? I was feeling sick. Yeah, that was it. But I went ahead and worked anyway, so you got to give me credit. Okay, let's look at our next problem. Want to find the integral of this. integral of 5 arc sine of x dx. Now, if I look at my my sheet, I'm looking through my my integration. I don't see any integral of arc sine. But if I look up in my derivatives, I see, okay, yeah, I do have a derivative of arc sine. So what I'm going to do is take the 5 out in front first. And the arc sine here, I'm going to let be u. And dx will be dv. That seems weird because it seems like, well, we didn't actually set equal to anything. But so u is equal to arc sine of x. And dv is equal to dx. Okay, so the derivative of arc sine. Now the formulas are arc sine u, you got u prime up on top, but derivative of x is 1 over the square root of 1 minus x squared. Okay, and then dx. Now over here, to find v, we're going to take the integral of dx, which there's nothing there, but there's always the invisible 1. So then the integral of 1 gives us x. So let's come over here. And we want to use uv minus the integral of v du. 5 remains out in front, times everything. U was arc sine. V was x. So multiplying that times x. Minus the integral of v, which was x. Oops. Try it again. X. And du, which was 1 over square root of 1 minus x squared dx. Okay, so I'll put the x out in front of that, so that's x arc sine of x minus, and then I'll put the x up on top, and we got the integral of 1 minus x squared dx. Now here I'm going to use my u substitution. I'll let u equal to 1 minus, boy, I'm slipping fast here. There. Let's try again. 1 minus x squared du. The 1 drops away. Derivative of negative x squared is negative 2x dx. Dx is there. The x is there, but negative 2 isn't. So I'm going to need to put a negative 2 inside, and I'll offset it by putting a negative 1/2 out in front. Because negative 1/2 times negative 2 would give me a positive 1. Like that. And then we got x, arc sine of x. Negative negative becomes positive 1/2. And now I can do my u substitution. Negative 2x dx gets replaced by du. And this gets replaced by u. So we got 1 over the square root of u du. And I'm going to rewrite that as 1 over u to the 1/2 du. And all the rest of this carries down. And I'll take that u to the 1/2 up on top, becomes u to the negative 1/2 du. And we're now ready to take the integral of that. So everything else carries down. Okay, so we'll add 1 to our power. Becomes negative 1/2 plus 1, and we'll divide by our new power. So negative 1/2 plus 1. And I'll put my plus c on here now. Okay, so then that gives us, all this carries down, still. Negative 1/2 plus 1 gives us positive 1/2, so this is u to the 1/2 over 1/2 plus c. Which gives us 5 x arc sine of x. This 1/2 cancels that 1/2, as weird as it seems. And we're left with this, and I could go ahead and put that back in the square root form, the 1/2 power, and plus c. Now I'm going to multiply the 5 through, so we've got 5x arc sine of x plus 5 square root, and I have no clue what u was, I've forgotten. Let's go up here. U is 1 minus x squared. So I'll put 1 minus x squared back in here, plus c, and that's our answer. These problems are long. Let me save this. There we go. It's time for that to blow up. Let me bring up another copy. There we go. Okay, so let's look at our next one. We looked at one similar to this already. But let's take a look at this. This is saying solve the differential equation. So they give us the derivative. To go backwards to find out what y is, we're going to take the integral of y prime with respect to x. Well, before we said when we have natural log of x, it's best to let that be u. And that still holds true. So I'm going to rearrange it in this manner. This is going to be our u. And this will be our dv. So over here, u is equal to natural log of x. And dv is equal to x dx. Excuse me. Derivative of u, du, is equal to 1 over x dx. For here, I'll take the integral of v is equal to the integral of x dx. Add 1 to my power, divide by my new power. So that gives us 1/2 x squared. Okay, so then we got uv minus the integral of v du. Oops, get rid of that. Okay, so u was natural log of x times v, which was 1/2 x squared, minus the integral of v, which is 1/2 x squared, du, which is 1 over x dx. Take the 1/2, put it out in front. Also put the x squared out in front, so 1/2 x squared natural log of x. Take the 1/2 and put it out in front of the integral. And we got x squared over x, which is just x. So then we got 1/2 x squared natural log of x minus 1/2. Now we got x to a power, x the first, so we add 1 to our power, divide by our new power. So that gives us 1/2 x squared. And I'll go ahead and put the plus c on now. And that gives us 1/2 x squared natural log of x minus 1/4 x squared plus c. And that would be your answer. Well, let's take a look at the next problem. You'll like these, I think. They're using the table method. Not all of them you can use the table method on. X dx. Now with table method, we're going to have 3 columns, S, D, and I. The I, or the S, is going to be our sign. So it starts with positive. Now our derivative, we want something that when you take derivative will disappear. Now e to the x wouldn't be a good choice because the derivative of e to the x is e to the x, so it would go on infinity. So we're going to choose x to the 4th. And the I over here is our integral. And you want to pick, this method only works if it's fairly easy to find the integral and the derivative. If it's really hideous, then probably there's not going to be a whole lot of benefit here. Well, with the derivative column, it starts out with x to the 4th. We keep taking the derivative. So this would be 4x to the 3rd, 12x squared 24x, 24, and 0. Now when do you stop? You stop when you get it down to 0. That's what, if it won't go down to 0, then you can't choose that for your derivative. Now signs alternate. That's plus, this will be minus, plus, minus, plus, minus. Now here we're going to take the integral of e to the x. So we're going to have the integral of e to the x, which is e to the x. And then we take the integral of that, which is e to the x, and then the integral of that, which is e to the x, integral of that, which is e to the x, and integral of that, which is e to the x. Okay, so how it goes is this sign here goes with that, and then you multiply that times this. This one goes with that, and then goes down with that one. This one goes with that one, and then down to that one. Goes with that, down with that one. That goes with that, and down to that one. Okay, so let's write our answer down. First one here, we got a positive, x to the fourth, e to the x. So x to the fourth, e to the x. Now the next one's a negative, 4x to the third, e to the x. So negative 4x to the third, e to the x. And then a positive 12x squared, e to the x. And again, I'm following arrows. Positive 12x squared, e to the x. And minus 24x, e to the x. Minus 24x, e to the x. Plus 24 e to the x. And then I'll put a plus c at the end. Like that. Now this last one you don't do anything with, but 0 times anything is 0. So now what the book's good about on this is that they all have an e to the x, so factor that out in front. And that gives us x to the fourth minus 4x to the third plus 12x squared minus 24x plus 24, and then plus c. And that's our answer. Let me save that, and then we'll start a new page. I think I'd be smart enough not to drink a lot of fluid before I started making these videos, but obviously I'm not a very smart person. Okay, so let's look at another one of those. Got the integral of x squared cosine 3x and dx. Now let's do our table. S D and then I. Okay, so this will be a plus. This will be our x squared, because that, when we take derivative, it keeps dropping away. So that gives us 2x. Derivative of 2x is 2. Derivative of 2 is 0. And this is plus, so this is negative, plus, negative. And we start out with cosine 3 to the x here. Now, if I think about the integral of cosine 3 to the x dx, this would be a u substitution. That would be our u. So u would equal to 3x. du would equal to 3 dx. So this would become cosine u. But I need a 3 inside, so I'll offset it with a 1/3 out in front. Like this. So this would become, oops, I need a 3 inside there. So this would be 3 dx. Okay, so it would become 1/3 cosine u du. And the integral of cosine is sine u. And then we put the 3x back in there, and we get 1/3 sine 3x. Now basically the 3x being our u means you put a 1/3 out in front. So we're going to use that to do the rest of these fairly quick. I already have a 1/3 out in front here, so if I take the integral of this, same idea, this would be our u, so we need a 1/3 out in front. We already have 1/3 out there, so that would be 1/9. And the integral of sine gives us negative cosine. So this would be cosine, but then this would be a negative here. And if you need to see the steps, go ahead and do them over here. Now take the integral of this again. And the integral, we got u is equal to 3x. We need a 1/3 out in front, so this would become a negative 1/27. And the integral of cosine is sine, like that. Okay, so this goes with that, and then that goes down with that one. This goes with that one, that goes down with this one. This one goes with that one, and that one goes down to that one. So this right here becomes positive x squared times that. Then minus 2x times that. Plus 2 times this. And then my plus c at the end. I rearrange those a little bit. So we've got 1/3 x squared sine 3x. Negative times a negative is positive. 2/9 x cosine 3x. And that gives us negative 2/27 sine 3x plus c. And that would be your answer. I don't know how hard this last one is. Let me take a look. Not too bad. Do I get enough room, though? Yeah, I think I do. It's another table method. It says find the definite integral 0 to 1 of x squared e to the negative 4x dx. Okay. So we got our s, d, I. And of course this will be our x squared will be here, because then take the derivative, it'll go away. Derivative of x squared is 2x, derivative of 2x is 2, derivative of 2 is 0. This is plus, always plus, and then it alternates. Now here we got e to the negative 4x. Now let's see what happens when we take the integral of e to the negative 4x. We have to do the u substitution, so I let u equal to negative 4x, du be negative 4 dx. So we need a negative 4 inside, so we'll offset it with a negative 1/4 out in front. Like that. Then this would become negative 1/4 e to the u du, which would give us negative 1/4 e to the u, which would give us negative 1/4, and u was negative 4x. So that's the integral of that. Now look, here we had e to the negative 4x. We still have a e to the negative 4x, but we basically put a negative 1/4 out in front. That's what that u substitution does on this. So this would become negative 1/4 e to the negative 4x. Now when we take the integral of that again we'll put a negative 1/4 out in front. Well, negative 1/4 times negative 1/4 gives us 1/16 e to the negative 4x. And again, that would put another negative 1/4 out in front, which would give us negative 1 over, was that 64? E to the negative 4x. Okay. That goes with that. This one goes with that one. That goes with that. This one goes with that one. This goes with that. And this one goes with that one. So, down here, we're going to have a positive x squared times that. Then we'll have a negative 2x times 1/16 e to the negative 4x. And here we have a positive 2 times the negative 1 over 64 e to the negative 4x. And this is from 0 to 1. probably easiest for me to, since they all have an e to the negative 4x, go ahead and factor that completely out in front. So e to the negative 4x times, and here we're left with negative 1/4 x squared. And here we got negative 2 times 1/16 gives us negative 2/16 or negative 1/8. So we got negative 1/8 x. And here's 2 times negative 1 over 64, which is negative 2 over 64, which is negative 1 over 32. 1 to 0. Okay, so probably not. I could maybe bring out the numbers, make it a little simpler. Yeah, let me do that. Let me factor out a negative 1 over 32. So we've got e to the negative 4x. And here we basically take 32 divided by 4 gives you 8. So that's 8x squared. Now the signs change. Negative divided by negative is positive. So this is going to become positive. And 32 divided by 8 is 4. So we got 4x. And that'll give us plus 1. And then let's plug in our numbers. So we've got negative 1 over 32. And so we'll have e to the negative 4 times 1 times 8 times 1 squared plus 4 times 1 plus 1 minus e to the negative 4 times 0 times 8 times 0 squared plus 4 times 0 plus 1, which gives us negative 1 over 32 e to the negative 4. These 1 squared is just 1, so that gives 8 plus 4 plus 1 minus anything to the 0 power. Negative 4 times 0 is 0. Anything to 0 power is 1. This drops away, and we've got 1 there. Gives us negative 1 over 32 e to the negative 4 13 minus 1. And this becomes 13 over e to the 4th minus 1. I don't know if they actually simplify that anymore beyond that, but if they do, and get a common denominator, this would be 13 over e to the 4th minus e to the 4th over e to the 4th, which would give me negative 1 over 32 times 13 minus e to the 4th over e to the 4th. And if I were to multiply these together, that negative 1 flips the sign of both of these, so this would be e to the 4th minus 13 over 32 e to the 4th. Those are 4s. I know they don't appear so well. And assuming I didn't make a basic math error, I feel pretty good about the calculus part up here, but assuming I didn't add or subtract numbers wrong, multiply, then that'd be our answer. Okay, so let's save that page, and then it's bathroom time. I quit drinking so much pop. So we stop. Time for that to blow up. That's okay. Stop the recorder. And what is this? Integration by parts.